Did Voyager 1 really cross a wall of fire at the edge of our solar system? And if it did, why didn't that impossible wall destroy the spacecraft in seconds? If you love space stories that get stranger the deeper they go, tap like, subscribe, and share this video with one curious friend before we dive in. Most people picture the edge of the solar system in a very simple way. They imagine a quiet line somewhere past Pluto, where the planets end and empty space begins. It sounds clean, it sounds cold, it sounds almost peaceful. But the real edge of our solar system is nothing like that. It is not a line you could draw with a pen. It is not still, it is not calm, and it is definitely not where most people think it is. Far beyond the planets, far beyond Pluto, and far beyond the neat pictures printed in school books, the sun creates a giant bubble around us. That bubble is called the Heliosphere. It is formed by the solar wind, a non-stop stream of charged particles that blasts outward from the sun in all directions. Those particles carry energy, they carry motion, they also carry the sun's magnetic field. So the heliosphere is not just a cloud. It is a moving magnetic shield wrapped around our entire planetary neighborhood. That shield matters more than it sounds. It helps block part of the harsh cosmic radiation racing through the galaxy. Inside the heliosphere, the sun is still protecting us in a way most people never think about. Earth sits inside it. Mars sits inside it. Jupiter, Saturn, Uranus, Neptune, and even distant Pluto sit inside it too. We live inside a giant solar bubble. And for most of human history, we had no idea what its outer edge really looked like. The reason is obvious. That edge is unbelievably far away. The solar wind keeps rushing outward for billions of miles, but it cannot win forever. Eventually, it collides with the material between the stars, a thin mix of gas, dust, plasma, and magnetic fields called the interstellar medium. That is where things get strange. You have pressure from the sun pushing out. You have pressure from the galaxy pushing in. Somewhere between them, those forces meet. Somewhere out there, our solar system stops being the main power in the neighborhood. Scientists had names for the layers of this outer frontier before any spacecraft reached them. First comes the region, where the solar wind still moves fast and free. Then comes the termination shock, where that wind slows down sharply. After that comes the heliosheath, a rough, compressed, chaotic zone where the solar wind becomes hotter and more turbulent as it piles up near the outer boundary. And then, at last, comes the heliopause, the place where the outward pressure of the solar wind is no longer strong enough to keep dominating the space beyond it. That is the true outer border of the heliosphere. Not the end of gravity, not the end of the Oort cloud, not the end of every object linked to the sun, but in a physical and magnetic sense, it is the point where interstellar space begins to take over. For decades, this was mostly theory. Good theory, careful theory, but still theory. No one had ever gone there. No one had ever crossed it. No one had ever touched the frontier and measured what it was actually like. Then Voyager 1 kept flying. That is one of the most incredible parts of this story. Voyager 1 was launched in 1977. It was built for a different job. It was never designed to become humanity's first interstellar scout. Its original mission was to study the outer planets, and it did that brilliantly. It gave us breathtaking views of Jupiter and Saturn. It transformed science. It earned its place in history long before it ever reached the edge of the heliosphere. But it kept going. Year after year, decade after decade, Voyager 1 kept moving outward. It left the planets behind. It entered regions no human-made object had ever explored. And in 2004, it crossed the termination shock. That alone was a historic moment. It meant the spacecraft had reached the beginning of the disturbed outer shell of the sun's bubble. The solar wind there was no longer behaving like the fast, smooth flow found closer to the sun. It had started to slow, heat up, and become more chaotic. What followed was not a quick pass through a thin edge. Voyager 1 spent years inside the heliosheath. Think about how huge that is. A single outer layer of our sun's influence was so vast that a spacecraft moving faster than most things humans have ever built still needed years to cross it. And during those years, the data kept getting more interesting. The particle environment was changing. The magnetic field was changing. The solar wind was no longer a clean outward stream. It was compressed, disturbed, and tangled. Instead of a calm boundary, the spacecraft was moving through a region that behaved more like a stressed outer skin. The closer Voyager 1 What came to the heliopause, the clearer it became that the edge of the solar system was not simple at all. Then came the moment that changed everything. In 2012, Voyager 1 saw a dramatic shift in the local environment. The lower energy particles linked to the heliosphere suddenly dropped. At the same time, higher energy galactic cosmic rays increased sharply. That was the clue scientists had been waiting for. Voyager 1 had crossed the heliopause. It had moved beyond the sun's magnetic bubble and entered interstellar space. That alone would have made the mission legendary. But then the real shock arrived. As scientists studied the boundary region, they found evidence that the plasma there was far hotter than many people expected. Not a little hotter, wildly hotter. Hot enough that headlines began describing the edge of the solar system as a wall of fire. It sounded impossible. It sounded dramatic. It sounded like the kind of thing that should melt metal and tear a spacecraft apart. And yet Voyager 1 survived. That is where this story becomes one of the best examples of how space can break human intuition. Because the phrase wall of fire is partly true and partly deeply misleading. In everyday life, we think of heat in a very human way. If something is extremely hot, we assume it burns. If air in a room reaches a terrible temperature, we know that room becomes deadly, but that is because Earth is full of dense matter. There are enough particles close together to transfer large amounts of energy into your skin, your clothes, or anything else. Space does not work that way. In plasma physics, temperature often describes how fast particles are moving on average. A plasma can have an extremely high temperature because its particles are moving with tremendous energy. But if the plasma is incredibly thin, if there are very few particles in a huge volume of space, then the total heat transferred to an object can still be tiny. That is the key idea. Temperature is not the same thing as the amount of heat something can dump into a spacecraft. So yes, the boundary near the Heliopause can be astonishingly hot in the technical sense, but it is also incredibly sparse. That means Voyager 1 was not flying into a solid curtain of flame. It was moving through a near vacuum filled with very energetic particles spread far apart. The region was real. The heat was real. But the danger was not what the headline made people imagine. Still, the obvious question remains, why was it so hot at all? One answer is compression. As the solar wind pushes outward and starts losing its fight against the interstellar medium, the plasma piles up. That compression can raise temperature. Another answer involves magnetic fields. The sun sends out magnetic fields with the solar wind. Interstellar space has its own magnetic fields. When magnetized plasmas meet, they do not simply slide past each other like two calm rivers. They can twist, strain, reconnect, and release stored magnetic energy. That process, called magnetic reconnection, can heat plasma and accelerate particles in dramatic ways. So the wall was never a wall in the solid sense. It was a boundary zone where motion, pressure, and magnetism were all colliding. It was a place where the sun's reach met the broader galaxy in a real physical struggle. And instead of being a neat shell, that frontier turned out to be active, layered, and far more intense than the simple public picture ever suggested. Pause for 1 second, because if this is already blowing your mind, give this video a like, subscribe for more deep space stories, and send it to someone who still thinks Pluto is basically the finish line. What Voyager 1 discovered out there was not just dramatic, it was important. One of the clearest changes it detected after crossing the Heliopause was the jump in galactic cosmic rays. These are high-energy particles produced by violent events across the Milky Way, things like supernova explosions and other extreme cosmic engines. The Heliosphere helps shield us from part of that radiation. It does not block all of it, but it reduces some of the incoming flow. That means the Heliopause is not just a border, it marks the edge of a protective zone. Inside the sun's bubble, the radiation environment is one thing. Outside it, the galaxy becomes harder to ignore. Voyager 1 did not just confirm where the Heliosphere ends. It confirmed that our star is constantly defending its own neighborhood against the wider cosmic environment. That changes the meaning of the mission. This is not only a story about distance, it is a story about protection. It is about understanding the invisible system that helps shape the space environment. The Heliosphere is not some abstract textbook bubble. It is a real structure with real effects. And then there was another surprise. Scientists expected the crossing to show a more dramatic change in magnetic field direction than Voyager 1. I understood it as someone first revealed. Instead, the magnetic field just outside the Heliopause appeared more aligned with the field inside than many had imagined. That hinted at something deeper. It suggested that the local interstellar environment around our solar system may be more connected to the sun's influence. In other words, the Heliopause is not a clean cut, where one domain stops and another begins with total independence. It is an interface, a relationship zone, a place where the sun and the local galaxy push, shape, and influence each other. That is a much richer picture than most people grow up with. We are taught the planets, we are taught orbits, we are taught the names of the major worlds, but the biggest structure in the solar system is not a planet. It is this enormous, invisible magnetic bubble carved out by the sun. And its outer boundary is not peaceful. It is under pressure from the galaxy itself. Even the distance to that boundary is not fixed forever. The heliosphere can expand and contract as solar activity changes. That means the heliopause can move inward and outward over time. The sun does not breathe in the human sense, of course, but its influence pulses. When solar activity changes, the The size and pressure of the heliosphere shift. So the outer border of our solar system is not frozen in place like the wall of a room. It is dynamic. That single fact should completely change how we imagine our cosmic home. We do not live inside a rigid container. We live inside a living bubble. The edge moves. The shield works. The boundary responds. And it took a spacecraft from the 1970s to show us all of that. There is something deeply emotional about Voyager 1 when you stop and think about it. This machine launched before laptops, before smartphones. It was built with less computing power than many ordinary devices today, and yet it traveled farther than any human-made object before it. It became the first craft to sample interstellar space directly. That is not just a technical achievement, it is a statement about patience and engineering. Voyager 1 keeps sending back information from unimaginable distance. Its signal is weak, tiny, faint beyond belief. By the time it reaches Earth, it is almost a whisper swallowed by the void. But giant antennas on Earth still hear it. Scientists still decode it. And from that faint trickle, we still learn. That matters because the discovery was never just one dramatic moment. It was the result of careful measurements, patient analysis, and years of watching how the particle environment changed. In movies, frontiers are crossed with noise and spectacle. In real science, they are often crossed in silence, revealed through graphs, signals, and patterns. Voyager 1 entered interstellar space quietly, but the meaning of that crossing was enormous. And the spacecraft is still powerful in another way. It reminds us how wrong our first instincts can be about space. We think of the outer solar system as empty darkness. In reality, it is shaped by invisible forces. We think of the edge as a line. In reality, it is a layered transition. We think high temperature means deadly fire. In reality, near vacuum plasma can be extremely hot and still fail to burn. Voyager 1 did not just discover a boundary. It corrected our imagination. That may be one of its greatest gifts, because imagination matters. The way we picture the universe affects the questions we ask. If you imagine the edge of the solar system as a dull, empty line, you do not ask the best questions. But once you understand it as a moving interface between the sun and the galaxy, suddenly the picture becomes alive. How does the boundary shift over time? How much does it protect us from cosmic radiation? How do magnetic fields reconnect there? What does that tell us about other stars and their own astrospheres? Now the story gets even bigger. Our sun is not the only star with a stellar wind. Other stars also carve out giant bubbles around themselves. That means Voyager 1 is not just teaching us about our solar system. It is helping scientists understand how stars interact with the interstellar medium. And that has consequences far beyond our neighborhood. If a star's outer bubble helps shield planets, then the size and strength could matter for habitability. So a lonely spacecraft at the far edge of our sun's influence is actually helping us think about alien worlds. That is the scale of this mission. One probe, one crossing, one set of instruments, and suddenly the lessons reach across the galaxy. There is also a quieter lesson here. Voyager 1 kept becoming more important because people refused to stop paying attention. Engineers kept nursing the spacecraft along as its power slowly declined. Instruments had to be managed carefully. Systems had to be protected. Hard choices had to be made. Over time, the mission stopped being about abundance and became more about precision. Every working instrument mattered. Every bit of power mattered. Every transmission mattered. That gives the mission a kind of emotional weight that newer projects sometimes lack. Voyager 1 is not a machine living in comfort. It is an aging explorer running on discipline and care. It is working at the edge of survival, and that makes every new scientific result feel earned. If you've made it this far, here's my request. Subscribe, hit like, and share this video so more people can see just how wild the solar system is. The more you think about Voyager 1, the more it feels almost symbolic. It began as a planetary mission. Then it became a mission about the boundary. Now it stands as proof that science often gets its biggest rewards from going farther than planned. That is such a human pattern. We build something for one purpose. Then, if we are lucky and persistent, it opens a door we did not know was there. Voyager 1 opened the door to direct interstellar measurement. Before that crossing, interstellar space was something humanity observed from the inside. We looked out at it through telescopes. We modeled it. We inferred its properties. But after Voyager 1 crossed the Heliopause, interstellar space became a place we could sample with actual instruments. That changes everything. Once you have direct measurements, your theories have to answer to reality. And reality turned out to be more interesting than the simpler guesses. The phrase, wall that should not exist, speaks to that emotional shock. Strictly speaking, physics allows a hot, compressed boundary zone. Scientists did not think the heliosphere simply faded into nothing. But the public image of the solar system's edge was much too simple. And even some expectations about the details proved incomplete. The boundary turned out to be hotter, more layered, and more dynamic than imagined. That is why the story grabs people. Not because the universe broke its rules, but because it shattered our cartoon version of reality. And maybe that is what great exploration always does. It does not usually reveal magic, it reveals complexity. It replaces the simple picture with the true one. The edge of the solar system is a perfect example. The true version is harder to imagine, but once you see it, it is much more beautiful than the old one. Think about what that means for future missions. If humanity ever sends probes designed for the long journey into interstellar space, they will not be entering some featureless emptiness right away. They will cross a real frontier with changing plasma conditions, changing particle populations, and changing magnetic behavior. The first step into interstellar space is not a blank doorway. It is a transition zone with physics of its own. Voyager 1 gave us the first direct look at that zone. It provided the first real ground truth. Not guesses, not diagrams, measurements. That makes the mission priceless. It is not just historically important. It remains scientifically powerful because we still use what Voyager taught us. We refine our understanding of the heliosphere and the interstellar medium around it. Even as newer missions study the sun, Voyager provides the reality check. There's also a poetic side to all this that is hard to ignore. Voyager 1 carries the golden record, a message from Earth meant for the unknown. It is a strange thing to include on a scientific machine, and also a perfect thing. The spacecraft is both instrument and artifact. It measures plasma waves and magnetic fields, but it also carries a portrait of our world, our sounds, our music, and our hope. So imagine the full picture. A machine built by human beings on one small planet travels outward for decades. It crosses the skin of its home star. It enters interstellar space. It finds that the frontier is not quiet, not simple, not empty, but hot, thin, dynamic, and alive with hidden forces. And all the while it carries a record of Earth like a bottle thrown into a cosmic ocean. That is not just science. That is one of the most moving stories our species has ever written in hardware. But the emotional power does not come from romance alone. It comes from the way the mission humbles us. We use phrases like our solar system as if we understand them completely. We name the planets. We know their moons. We talk about the sun like it is familiar. Yet one of the biggest structures remained abstract until a spacecraft touched it. That should remind us how much of reality can remain invisible even in our own backyard. And that humility is healthy. The same lesson applies everywhere in science. The universe is not required to match our first guesses or be simple for teaching. Nature does not care about our diagrams. Voyager 1 is powerful because it forced us to replace a clean picture with a true one. The edge of the solar system is not a quiet finish line. It is a battleground of plasma and magnetic fields. It is a shield against radiation. It is a moving boundary. It is a transition from the sun's dominance to the wider influence of interstellar space. And yes, it includes regions so hot they sound terrifying, even though they are too thin to burn a probe the way our instincts expect. That single combination of ideas is why this story feels unforgettable. It sounds impossible until you understand it. Then it sounds better. There is another human lesson buried here too. Voyager 1 shows the value of long projects. This mission is the opposite of instant results. Decades passed between launch and the crossing of the Heliopause. That means the builders could not control the full meaning of what it would become. They had to trust the future. They had to build something durable enough to outlast the moment that created it. That is rare and beautiful. Voyager 1 is proof that achievements come from work done for people we will never meet and discoveries in decades we may never see. That slow truth arrived as a faint radio signal from a tiny spacecraft billions of miles from home. It told us the edge is real, active, and strange. It told us that our sun protects us more than we knew. It told us that interstellar space begins not with emptiness, but with negotiation. And maybe that word matters most, negotiation. Because the heliopause is not one force beating another into silence. It is a meeting point. It is where the sun's influence and the galaxy's influence meet, resist, and shape each other. It is a frontier built by balance and change. That makes it feel less like a wall and more like a living conversation written in plasma. That image stays with me. A border made of pressure, a shield made of solar wind, a wall of fire that is real, but not in the way our instincts imagine. A spacecraft from another era passing through all of it and calmly sending the results home across the void. By the time we receive those results, the signal has traveled for hours. Scientists collect it, decode it, and slowly pull meaning from it. No dramatic soundtrack, no giant explosion, just a whisper from the frontier. That may be one of the purest forms of science there is. When people ask whether Voyager 1 passed through a wall that should not exist, the answer is it passed through a boundary far stranger than imagined. It showed us that home has an outer skin. It showed us that the skin is under pressure. It showed us the galaxy is pressing back. And it showed us that a machine built nearly half a century ago could still walk us right up to the edge of human understanding. That is the real power of Voyager 1. Not just that it went far, but that it turned distance into knowledge. It made the invisible visible. It took a phrase like edge of the solar system and replaced it with something far more vivid and true. Not a quiet line, but a moving frontier. Not emptiness, but interaction. Not the end, but a beginning. Once Voyager 1 crossed the Heliopause, humanity entered interstellar space, and that may be the most powerful part of all. We crossed into the space between the stars, not with a grand ship, but with a patient machine. If that kind of story deserves a place on your screen, subscribe and share so we can follow the machines that carry curiosity farther than we go. Voyager 1 is still out there, still moving, still turning the dark into data, and somewhere beyond the sun's bubble it keeps reminding us the universe is always more alive than our first picture of it.